Now that we've learned what Taylor polynomials and Maclaurin polynomials are, let's do our first example of actually calculating a Maclaurin polynomial. Now I did kind of spoil the answer to this one earlier. I showed you what a general nth degree Maclaurin polynomial was for this, but this is going to be great practice for us to use the formula here and come up with it ourselves. So the general process here, since I'm going to need each of these terms that looks like some derivative of f plugged in at 0 times x raised to a power, is first I just need to find those derivatives of f. So what I typically do is find the first 3 derivatives of f at least. Okay, so let's start with that. My function is e to the x. The derivative of e to the x, still e to the x. Second derivative, still e to the x. Third derivative, still e to the x. I'm eventually going to go all the way to the nth derivative. Well, you can kind of see the pattern here. Doesn't matter how many derivatives I take, it's just going to be e to the x. After I do that, I'm going to go ahead and plug in the number. Alright, now a Maclaurin polynomial says we should be plugging in 0. That's exactly what's written in the formula here. So my next step is to find each of those, the function and the derivatives, with 0 plugged in. That's the center of our Taylor polynomial. Alright, so let's see. If I did e to the 0, that would just be 1. Alright, f prime would also be e to the 0, which is still 1. And it turns out each of these guys is just going to be 1. Alright, so I've done the hard work now. Now I'm just going to try to use this formula and plug in my terms. So, the degree n Maclaurin polynomial, I would start with f of 0, which is 1. F prime of 0 is 1, times x. F double prime of 0 is 1, so 1 over 2 factorial times x squared. F triple prime of 0, that's also 1 over 3 factorial times x cubed. I would keep adding stuff all the way to, let's see, the nth derivative evaluated at 0, still 1 over n factorial times x to the n. Okay, so we just found the degree n Maclaurin polynomial for e to the x. And again, if you remember from what we did before, I claimed that we could come up with that, and that's exactly what we just did. So just to give us some practice writing this in sigma notation as well, in general I want to describe what's going on with the term that is x to the n. So I've got something times x to the n, okay, but actually I'm going to stop at x to the n, so let's use a different letter. Let's do k. So I'm going to figure out what the coefficient is that goes with the term x to the k. So let's see, if I had k equals 1, I would just have 1. If I had k equals 2, I would have 1 over 2 factorial. K equals 3, 1 over 3 factorial. So it looks like it's just 1 over k factorial. Okay, so some important things to remember here. Okay, 0 factorial is equal to 1, just by definition. 1 factorial is also equal to 1. Okay, so I'm just summing from k equals 1 all the way up to k equals n, 1 over k factorial times x to the k. So that would be how I would write that in sigma notation.